Hello guys, this is Siddharth of SS.Embedded World. Today I'm gonna explain you how to generate a square wave using 8051 controller. In order to implement this project, you need to download the Proteus and Keil software. If you already have them, it's cool. You can do your simulation and program your controller. If not, don't be sad. We have done some videos on them. Just click on the card above on the screen and you will be redirected to them. In order to generate a square wave, we need to use the timer registers. Now, I will give you some introduction about timers and counters. There are two 16-bit timers present in 8051 which are used for timing and counting purpose. A timer is used for providing delay. It depends upon the crystal frequency, whereas a counter is used for external counting purpose and it depends upon the external event rate. Like when you connect a push button to one of the pin and press it continuously, the rate at which is pressed is considered as the external event rate. Here is the internal circuit of the timer. There are two inputs, the timer input and the counter input. The timer input is the crystal frequency which is divided by 12 and the counter input is the one which is connected to the pin 3.4. There is a logical bit C by T bar to select the counter or timer input. If C by T bar is equals to 0, then you can select the timer input. And if C by T bar is equals to 1, then you can select the counter input. There is another logical switch in order to access the timer registers like TH0, TL0. In order to conduct the switch, you have two logical gates like AND gate and OR gate. As we know, we can obtain the logic 1 output from the AND gate if both the inputs are 1 and logic 1 output from the OR gate when any one of the inputs are 1. Here the inputs to the AND gate are TR0 and the output of the OR gate. So both the inputs of the AND gate should be 1. Hence TR0 should be always 1. Now the output of the OR gate can be 1 when any one of its input are 1. So the inputs to the OR gate are the gate bit which is present in the TMOD register and the interrupt pin 3.2. If gate is 0, then the output of it will be 1 as there is a NOT gate in between. Then the logic switch will be activated and we can access the timer registers. This is called as internal control. Now if the gate is 1, then the output of the gate will be 0. Then the other input of the OR gate should be 1, which can be obtained by connecting an external hardware device, so it is called as external control. This is how the internal circuit of the timer 0 looks. You can also find the same structure of the timer 1 also. Now let's take a look at the timer registers. They are responsible for giving data to the timer like delay and use it to select different options. Now firstly, there is timer 0 register which is a 16-bit register. It is internally divided to TH0 and TL0 which are 8-bit respectively. And there is another register called as timer 1 register which is also a 16-bit register and it is also internally divided into TH1 and TL1 which are both 8-bit respectively. Now we will take a look at the TMOD register. It is used to select the mode of the timer and it is not bit addressable. That means you cannot address it bit by bit. Here as you see, these 4 bits belong to timer 1 and the other 4 bits belong to timer 0. And here you can take a look at the gate and C by T bar bits which you have already seen them in the internal circuit. Now we will discuss about the bits M1 and M0. They are used to select the mode of the timer. Here is a table in order to select the mode of the timers. If M1 and M0 are 0 and 0 respectively, then it is considered as mode 0, which is a 13-bit operating mode and THX occupies 8 bits and TLX occupies 5 bits. If M1 and M0 are 0 and 1 respectively, then it is considered as mode 1, which is a 16-bit operating mode and THX occupies 8 bits and TLX occupies 8 bits. When M1 and M0 are 1 and 0 respectively, then it is considered as mode 2, which is a 8-bit auto reload mode. And when M1 and M0 are 1 and 1 respectively, then it is considered as mode 3, which is a split timer mode. Now we will take a look at 8-bit auto reload mode and split timer mode. In 8-bit auto reload mode, we will be using two 8-bit registers which are THX and TLX. The initial value is provided and it is also copied to THX and TLX. Delay is provided as per the initial value in TLX until the flag bit is raised, and the initial value which is present in THX is also copied to TLX and the process continues. For example, let us copy the value 125 into TLX and THX. Then the delay is provided until it reaches 255 in TLX and the flag bit is raised. Now the initial value in the THX is copied to TLX and the process continues. There's an important note for you guys. See that the same value is copied into TLX and THX. Otherwise, the delay during the first cycle will differ from the other cycles. Now we will take a look at the split timer mode. In split timer mode, T1 is used when no interrupts are present, and T0 acts as TL0 and TH0, which are 8 bits respectively, where TL0 is used as counters and also timer, and TH0 is only used as a timer. Here TL0 uses T0 bits of Tmod and TH0 uses the T1 bits of Tmod. Now we will take a look at the TCON register. It is used to control the timer. It consists of the timer run and flag bits. Here, as you look, these 4 bits belongs to the timer and the remaining 4 bits belongs to the interrupts. TR1 is the timer run bit and TF1 is the timer 1 flag bit. TR0 is the timer 0 run bit and TF0 is the timer 0 flag bit, where IE1 and IE0 are the interrupt status bits and IT1 and IT0 are the interrupt flag bits. Now let's take an example and see how we can calculate the delay. Here we have considered that the count to be loaded into the timer registers to generate a time delay of 500 microseconds using timer 0 and mode 1, where the crystal frequency is 12 MHz. Initially we will be calculating the timer frequency as you have already seen it in the internal circuit. The input to the timer is divided by 12. So we have done that process. Here the 12 MHz is divided by 12 and we have obtained the result as 1 MHz. Now the time taken for each pulse is calculated by the inverse of the timer frequency as 1 divided by 1 MHz and we have obtained 1 microsecond. Now the timer pulses required to produce a delay of 500 microseconds is calculated by dividing the time delay by time taken for each pulse, which is 500 microseconds by 1 microsecond, and we have obtained 500 timer pulses. Now the initial value is calculated as we have selected timer 0 and mode 1. It is a 16-bit mode which is 2 power 16 and we have obtained 65,536, and it is subtracted by the 500 timer pulses and added with 1 in order to consider the flag bit, and we have obtained 65,036, and this value is converted into a hex value and we have obtained FE0CH, and this hex value is divided and stored into TH0 and TL0. This is how you will be calculating the delay. Now we will take a look at the algorithm which we will be using in the code. Initially you need to set the Tmod register, then calculate the value to be loaded into the timer registers TLX and THX. Then start and run the TRX bit. Then check for overflow of the timer, which is the TFX bit. Then clear the TRX and TFX. This is some brief introduction about timers and counters. The document is also available for you guys. Just click on the link below in the description and you can find it. Now we are gonna implement the logic in the Keil software and program our 8051 controller. The code is also available for you guys. The link is below in the description. Now I will explain you the code. In this code we have used the 8-bit auto reload mode. Here we have set the Tmod register and selected the 8-bit auto reload mode. Then we have calculated the delay and stored the initial value in TH0 and TL0. Then we have set the timer run bit. Then we have created a label as loop. In this step we have been checking if the flag bit is set or not. If the flag bit is not set, then we will be jumping to the same line. If the flag bit is set, then the loop breaks and we will go to the next step, which is the clearing of the flag bit. Then we will be complementing the pin P2.0 and then jump again to the label loop. In this code we have not initialized the pin P2.0 as in 8051 all the pins are initialized as logic 1, which is plus 5 volts. Now we will build the code and see if any errors are present. To build the code, just press on the button F7 or the icon which is present on the toolbar. As you see, there are no errors. The hex file is also created. Now we will debug the code and check our results. To debug the code, just press on Ctrl plus F5 or on the debug icon which is present on the toolbar and click on OK. This is how the debugging space looks. You can take a look at the status of the registers we have been using in the code in the call stack plus local space. Now we will be debugging the code. In order to debug the code, just press on the step which is present on the toolbar. Now as you debug, you can observe the values which are changing in the call stack plus local space. Here as you see, the value of the TH0 has been changed to 0xD2 and TL0 is also changed to 0xD2. This is how you can view it in the call stack plus local space. Now just press F11 key and continue debugging. As you continue debugging, at the end of the process, you can observe that the logic 1 has been changed to logic 0 in the pin P2.0. Now again we will debug the code and again see how the value is changing in the pin 2.0. Again, as you see, the value has been changed from 0 to 1. This is how you can generate the square wave. Now we will take a look on the Proteus simulation and see how the square wave is generated. In order to generate a square wave, you just need 8089C51 microcontroller and an oscilloscope. Here, the oscilloscope consists of 4 channels. You can connect any one of them. We are generating a square wave from the pin P2.0 of the controller. If you click on the play button, the oscilloscope opens automatically and you can view the output. Here you can see how the oscilloscope looks, and if the oscilloscope has been closed by mistake, then you can find the oscilloscope in the debug tab which is present on the taskbar. Just click on the debug and you can find the digital oscilloscope. Just click on it. Here's again you got the oscilloscope. Now in order to run the simulation, you need to select the hex file. In order to select the hex file, just double click on the microcontroller and you will find the program file. Just browse it. Then just select the hex file and click on open and then OK. Now in order to run the simulation, just click on the play button. To view the output, it is better to switch off all the outputs of the other channel. You can switch off the outputs of the other channel from here. This is how you switch off the other channels. Now we will see how to view the output. You have 3 different features. If you just click on the auto, you can view the output and the output is produced continuously. If you click on the one shot button, then you can view the square wave at a particular instant of time. And by checking on the cursor box, you can measure the amplitude and time period of the square wave easily. Here the oscilloscope is similar to that of the physical oscilloscope you see guys. It also has the channel A, B, C and D. This is how the square wave is generated using 8051 controller. Please like, share and subscribe to SS Embedded World and click on the bell icon for further updates.